Hello, welcome back to Blender Sushi LIVENODING. In this episode, I'm gonna share with you just a very simple example using Blender and Sonic Pi to generate sound and noise. And I said it is like a very simple example because really what I'm trying to do here is to send like a single OSC message, like a value from Blender. A very short script here. This is written in Ruby, but basically this is a live loop and kind of listening to the OSC message from animation nodes. And it's I call it this line I call it just frequency, but from this array of value I'm getting the first array and using it to play a frequency using Sonic Pi. So yeah, you can see if I'm changing a value inside Blender, and that's the sound being generated is basically this value right here. Inside Blender, using animation nodes, I'm basically just using this very simple script node, and this node is using a module called Python Sonic. So it's importing the module and sending the message. This is the OSC message, and this is the line or the address going into Sonic Pi. So whenever I change the frame, it's gonna send like a very dynamic value into Sonic Pi. This is actually can be, you can adjust this in real time, and I don't want to go too detailed, but yeah, I think basically if you set it properly and run it, now it's listening again. Back to Blender. Okay, runtime error. So every now and then it's gonna hit this runtime error if your computer is not fast enough to handle. Currently I'm recording, so keep that in mind. Perhaps I have to try run this again, and back to animation nodes, Blender. Now it's working. The thing about Sonic Pi is that it's kind of very dynamic. So whenever you make changes here, it will actually create like multiple threads. And it's if you're kind of, if I'm like playing this in real time, it's gonna send and generate message, lots of message into Sonic Pi and to generate sound. So this might be actually what you want, and it can be real time, but depending on how powerful your computer is, because I'm recording, this is like 10 times slower or even slower than 10 times. So I cannot just like, if I try to run this, it's gonna try to send a lot of message into Sonic Pi and generating all this random sound. But maybe, but I can always record it if I like. If I hit record, and now it's recording this performance, and if I play back, and it's gonna actually save it as a wave file. I'm reducing this playback into 1 frame per second, but even this kind of still pretty fast. Still a lot of processing power is being generated. You see, it's sending all this OSC message, and then this Sonic Pi is gonna try to generate message. But my takes on this is that if I make this full screen, I think should be a lot faster and less processing for Blender. Now it's generating all this sound, and I can change the scene, for example, to different sound, and let's try using like a chip bass. See this, all these numbers that's coming from Blender, and animation nodes is generating the sound. Let's see if I can change this. Let's stop this for now and back to this guy. Run it again. So yeah, it's trying to do all this as fast as it can. If I want this to be like totally real time and like a real performance, I will be probably using different machines. I might try actually using my Windows machine and using these Mac machines and try to control Sonic Pi. Sonic Pi should be running on the Mac, and then I'm using Blender on my PC computer, and we can perhaps generate a more interesting sound. So it's not, I think, a totally random sound tend to be uh, not so pretty when you listen to it, but this is still a pretty fun experiment if you want to try. The Blender just keeps sending message. I'm gonna stop it. Okay, currently I'm using this random number, but really I can just control this using my mouse. And let's try. Is animation nodes running in real time? Yep. Okay, now it's in tune. So that's frequency 500. This is 1000. Yes, you see 1000. So yeah, I think there's a lot of things to learn and to explore here. Basically, if you are very proficient with Sonic Pi and also with Python and then with Blender, you can really create a very interesting visualization, or even like some kind of sound triggering system in Blender that you can send into Sonic Pi. I'm still thinking for ideas like a proper way to do this, but yeah, this is as simple as I can show you using Sonic Pi and Blender to generate sound properly. So in this case, I'm using these functions that convert the hertz into MIDI. Yeah, but there's a lot of ways you can generate sounds. I highly recommend you, if you're interested with sound programming using codes, Sonic Pi is really good, and yeah, and then combine it with Blender, you got really powerful tools to perform and give like a some kind of entertainment for other people. So yeah, I guess that's pretty much it for this live coding. Thanks again for tuning in. I'll see you next time.